you as well. Leroy, it looks like we lost telemetry here. It looks like we think that they still have some sort of contact to let them know that this is re-entering. Oh, any idea what's going on up there?
No, I don't have any more insight than you do on what's happening. It looked like there was a bit of a loss of control. Not sure what the status of the vehicle is. I mean, but the good news, as you all pointed out, is that a refurbished Falcon Super Heavy successfully launched the Starship into space, and all the Raptor engines on the Starship ignited, went through a full burn, and then later on there was some kind of a leak and some kind of an issue. So, this is how you do things more quickly, or most quickly, is to test, break it, fix it, and just repeat. And that's what we're seeing, and that's why the Starship system has been so, advancing so rapidly compared to, conventional rocket programs like NASA's SLS.
And again, you're looking at images from just a little while ago, if I'm not mistaken. This is what it looked like as it was approaching re-entry. But at this point, we have lost communication. So this was just a few moments ago. But Leroy, when we're talking about these heat shields, if I understand this correctly, they are trying to stress test the living daylights out of this, right? And that means taking heat shields off in certain areas to see if, like maybe this thing doesn't need heat shields here, possibly cooling down heat shields with some sort of active cooling mechanism in other areas. How close do you think they are to really dialing in how much heat shielding this thing needs to be able to land it, throw some more fuel in it, shoot it up the next hour, land it, throw some more fuel in it, shoot it up an hour after that? Because that's what the cadence is supposed to be, right?
Oh, sure. Yeah, and that's the goal, of course. And this Starship, obviously, with probable loss of control, it's unfortunate. And the last two before it also had loss of control and issues and exploded. But before that, several Starships did come back through the atmosphere with damage. The heat shield, they hadn't gotten it quite right, but with each successive entry, it was getting better and better. And in fact, the last one, at least, was able to demonstrate a hover over the Indian Ocean before it, went into the ocean, to demonstrate its ability to do what the booster does, which is hover over the launch pad and get grabbed by those chopsticks, right? So even though this one didn't work out, I would imagine they've got some good telemetry, some good data about the heat shields. The heat shielding tiles, they're not unlike the ones that were on Space Shuttle. They're probably more advanced, I would imagine, but it's the same kind of idea, a very light, low density silica, kind of a composite with a harder, probably silicon carbide or coating on the bottom. And, they have to, some of those probably will have to be replaced after each use, just like they were on the shuttle, but very much a reusable system. So hopefully we'll learn more soon.
And Gotti, I will jump in with maybe the same thing you were going to say, which is we just got an update from the live stream that they officially lost comms. I'm seeing people paying their tributes online as we speak on X saying RIP. A lot of that happening in space Twitter, SpaceX world.
And we will be refreshing the SpaceX and the X, platforms to see if there are any captures from the ground of what could be a light show above. I do want to play an interview just a little while ago that was with Everyday Astronaut, an amazing communicator out on YouTube, and Elon Musk about the heat shield. And if we have that, can we play that real quick?
It's pretty hard keeping tiles on a rocket when it is shaking more shaking than you could possibly imagine shaking would be.
Yep.
Like the vibration and acoustics are beyond human comprehension.
Yeah.
And the ceramic tiles are basically brittle, they're like a coffee cup or a dinner plate. So got this whole shaking metal rocket that's got cryogenic propellant, so it's shrinking due to the cryogenics, then it's being pressurized, so it's puffing up like a balloon.
Leroy, hearing that and just thinking about the acoustics, the shaking, the expansion and retraction of metal, what do you think is the hardest engineering problem when it comes to making heat shields something as easy as keeping them on and then reusing them every day?
Well, sure. Now, bear in mind, the space shuttle made its first flight in 1981. And so, it's faced a lot of the same challenges that Starship is facing, although the additional one that Elon Musk just mentioned in the video were the cryogenics on board. Of course, we had we didn't have cryogenic fuels on board the shuttle. I mean, we had liquid oxygen, of course, as an oxidizer for the orbital maneuvering engines and the thrusters. But the challenge, the additional challenge with the cryo is going to be a factor. But the technology for these ceramic tiles has been around for a number of decades, and so SpaceX does face more challenges than Space Shuttle did. But my point is that they will solve it. They'll figure it out because the basic technology has been around for quite a while.
Yeah, and we will await the lessons learned. Leroy Chow and Marissa Parra, I always love talking space with you guys. You guys are the best. Thank you so much. And don't go anywhere. We are just getting started. Up next, Trump versus Harvard. The clash between the president and the university is heating up as the administration